Hi guys, this is Sean from Alexander Tutoring, and in this video we're going to derive the quadratic equation. This is for my advanced algebra students. All students memorize the quadratic equation, and it seems like it just is this thing that comes from outer space you have to memorize. It actually comes from somewhere, and we at Alexander Tutoring, we find that's where the magic is in understanding where these formulas come from. So I'm going to derive the quadratic formula for you. This video will assume that you know how to complete the square. If you don't know how to complete the square, I will make another video for you. Okay, so quadratic equations are equations of the following type. A, B, and C are constants, numbers to be determined. And x squared and x, those are variables. So basically, we want to find the value of x that makes this equation true. Now, because a, b, and c could be anything, by solving this equation in terms of a, b, and c, we can solve any quadratic equation. So here's what we're going to do to start. Let's get rid of this pesky c term. So I'm going to subtract c from both sides of the equation. Draw a line right underneath. Equal sign comes straight down. And we get negative c on the left-hand side. And we're left with ax squared plus bx on the left-hand side. Next, I'm going to get rid of this pesky a term in front of the x squared. And so we'll divide both sides by a, being careful to divide the whole side. And then on the left-hand side, that a is going to divide both terms up top. On the left, it cancels to get x squared. And over here, we get b over a times x equals negative c over a. Again, we're trying to solve for x, which is tricky because there's an x squared term and an x term. Now, what we'd like to be able to do is factor this guy over here. Obviously, that's a little tricky with a little b over a here. So this is where we need to complete the square. That's the trickiest step. We want basically a perfect square so we can factor this guy, which will allow us to solve for the x. So if you recall from when you learned completing the square, the term that we want to add to both sides that gives us the perfect squared is always the coefficient of the x term, this guy, divided by 2 squared. I'll explain that in a second. So the term that's going to complete the square is b over 2a. That's what we want to add to both sides. Again, I'm assuming that you've seen that from completing the square. So I'm going to add b over 2a squared to both sides, and I'll show you why that works in a second. Okay, we can't just stick it on the left-hand side, excuse me. We got to add it to both sides. Okay. Now, normally when factoring quadratics on the left, you want to think of two numbers that add to the middle term and multiply to the c term. Now, it's a little tricky to see what the answer is, but it's actually b over 2a, because b over 2a plus b over 2a, or half of b over a plus half of b over a, is b over a, and b over 2a times b over 2a is b over 2a squared. See how that works? That's why this whole completing the square thing works. And what that allows us to do is factor the left-hand side to get x plus b over 2a squared. I encourage you to FOIL that out to see that we get back to where we started. You get x squared plus b over 2a plus b over 2a to get b over a, and then b over 2a times b over 2a to get b over 2a squared. So it works. Okay, we'll just keep the right-hand side the same. See, now the reason we wanted to factor this is because we can now square root both sides, and we're starting to get our way to the x, right? We're after this guy. The cool thing about factoring is you'll notice that, see that x isn't squared anymore, so we can actually get to it. So now we're going to square root both sides of the equation. Okay, so on the left-hand side, it just cancels the square to get x plus b over 2a. We can actually get to the x now. Equals, don't forget your plus or minus when you square root both sides. You always got to do that. the square root of negative c over a plus b over 2a squared. I'm going to go ahead and square that guy out to get b squared over 4a squared. Okay? We can subtract the b over 2a from both sides to isolate the x, which means we're basically there. And then it's just cleanup from that point. Okay? To get x equals negative b over 2a plus or minus the square root. Now I'm going to flip the order of this. I'll show you why in a second. I'm going to put b squared over 4a squared first, minus c over a. So we've essentially solved for x. That's our goal. It doesn't quite, it almost looks like the quadratic equation you're used to. We're just going to clean it up a bit. So inside the square root, I'd like to get a common denominator so I can combine those fractions. So I can do that by multiplying this guy by 4a over 4a. And you can see that that gives you a common denominator. Okay, and then this way we have c times 4a, or 4ac, divided by 4 times a, or 4a squared. There's our common denominator. We can now combine those fractions. To get b squared minus 4ac all over 4a squared. Now that it's just one fraction under the square root, we can square root the top and square root the bottom. Getting close. And then the bottom, we can square root 4a squared to simply get 2a, which is cool because you'll notice with the these two fractions now, we also have a common denominator. So we are free to put it all over the same denominator, equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Boom. And that is the quadratic equation that you all learn in school. Now again, pretty much every school just tells you to memorize that. But the cool part is figuring out where it comes from, which we just did. And because we just use a, b, and c, which could be any number for the coefficients, that means we can solve any, remember where this came from, we started up here. We can solve any quadratic using the quadratic formula for any values of a, b, and c. I hope you enjoyed that as much as I did. Have a good day. Bye.